Alright guys, so we have one more section to cover before we can quiz tomorrow, so I just thought I would just go through that pretty quickly here. And we're graphing inequalities. So we're going to start out by looking at inequalities that are in two variables. We've talked about inequalities in one variable, but now they're going to look like equations, except they won't have an equal sign. So linear inequality in two variables is created by replacing an equal sign with an inequality. Pretty straightforward. A solution to a linear inequality in two variables is an ordered pair, x, y, that creates a true statement when substituted into the expression. So if we look at the inequality up above, x is greater than 3y plus 7. Down at the bottom, we are testing 5, negative 1 to see if that's a solution. So we're plugging in 5 for x and plugging in negative 1 for y, and then testing to see if that makes a true statement. So this is still a 5. Greater than 3 times negative 1 is negative 3 plus 7 is 5 greater than, well, that would be 4. And yes, it is. That's true. 5 is bigger than 4. So yes, this is a solution. It is not the only solution. There are many solutions that work. For example, if we lock down the negative 1, and we're going to use that for sure, any number bigger than 5 will also be true. Because as long as I just increase this guy, if I keep making that bigger, this will still be true. It will still be greater than 4 no matter what, as long as the number is at least 5 or more. There are infinitely many solutions to these. That is just one of them. Okay, so I want you to take a second and look at this and decide which ordered pair is not a solution of x minus 3y is less than or equal to 6. And there's 4 ordered pairs to choose from. You're just going to plug those in and work it out. If it's a true statement, it's a solution. If you end up with a false statement or something that's not true, like 2 is greater than 7, then that is not a solution. So take a second, pause the video, and try those real quick. Okay, so let's check these. 0 minus 3 times 0 less than or equal to 6. Well, that's 0. 0 minus 0 is still 0. That is true. So that is a solution. So let's try the next one. 6 minus 3 times negative 1 less than or equal to 6. That's 6 plus 3, because negative times a negative is a positive, less than or equal to 6. Is 9 less than or equal to 6? No. So this would not be a solution. Right? If we check these ones too, we'll see that they work. That's 10 minus 9. That's 1, which is less than 6. Same thing here. Negative 1 minus 3 times negative 2. Negative 1. Again, that's going to be positive because a negative times a negative is a positive. Plus 6 less than or equal to 6. That's going to be 5, which is less than or equal to 6. So B is the only option that does not work. B is not a solution. Okay? And again, it's not the only solution. Obviously, here are 3 different ordered pairs that are solutions, right? A, C, and D are all solutions that do work. There are infinitely many solutions that make this true. There are also infinitely many that do not make it true. These are just a sample of those. The graph of a line represents all values that make the equation of that line true. Every ordered pair on a line that is a graph of a function, every one of those ordered pairs would make that equation true if we plugged it in. The same is true of an inequality. It's the graph of an inequality is the set of all points that make the inequality true. Within that graph, and again, we're talking about graphs with 2 variables. We've already graphed inequalities with 1 variable. So within a graph of an inequality with 2 variables is what we call a boundary line. And it is just a graph of a line that divides the coordinate plane into 2 half planes, or just basically, cuts it in half. One of those halves will contain all of the points that do satisfy the inequality, and the other half contains all the points that don't satisfy the inequality. And a quick note about a half plane. Here's our axes. Let's say we graph it, and let's say maybe our graph's only this big on the page. Right? If I graph something, some inequality boundary line, and it comes up here, you may not think that that is half, but you have to remember that this coordinate plane goes forever in all directions. So it doesn't really matter where the line goes. It's going to be half, right? It may not look like half of the view you're looking at, but the space is infinitely large. So don't get too hung up on the idea of a half plane being exactly half of the graph you see. It's just taking this enormous, infinite sheet of paper and drawing a line all the way through it is what that's talking about. Half of one side of the line is all the solutions, the other side of the line is all the things that are not solutions. Okay, so let's look at this one. This one's already done. We're just going to walk through it. Y is greater than 4x minus 3. Okay, so first we're going to graph the line. So we can do that any number of ways. We can do it by plotting points in a table. We could do it by finding intercepts. We could use the slope and the y-intercept, which is what I would suggest doing since it's in slope-intercept form. Y-intercept is a -3, so we start at -3. Slope is a 4, so we go up 1 over 4, and we draw our line. The next thing we have to decide, notice we graphed an equation there, right? But the initial expression was an inequality. We have to decide if we need a solid line or a dashed line. So just like before when we were doing one variable inequalities, if it was open, if it was just greater than or just less than, it was an open dot, correct? And if it was less than or equal to and greater than or equal to, we used a closed dot. Well, now that we're doing inequalities with two variables, it's not going to be dots anymore. We're deciding what the line looks like, but the line has the same effect as the dot. So if it's open, we're going to use a dashed line to represent our boundary line. If it's closed, we use a solid line. And it means the same thing. A dashed line means that we can get really close to the line, but we can't actually be on the line. Solid line means the points on the line are solutions also. In this situation, we do not have the equal to, so we will use a dashed line. The last step is deciding which side of the graph we're going to shade. Because remember, half of that graph, or one side of the line, every single point over there is a solution. The easiest way to test whether or not, or which side we need to shade, is to just pick any point that does not happen to be on the line. So 0, 0 is always a good choice as long as the line doesn't go through 0, 0. Plug it in and see if it gives you a true statement or not. In this case, it does give you a true statement. 0 is greater than -3. That means that 0, 0 is a solution. That means that everything on that side of the boundary line is a solution. So we're going to shade this side. It was already shaded blue. I don't know if you could see that or not. But we're going to shade everything on that side. Everything in the red is a solution of the inequality. The points on the line are not solutions because it's a dotted line. And everything on the right side of the line or below the line is not a solution also. So that's it. 3 steps. Graph the line. Step 2, decide if it's solid or dotted. Step 3, decide whether we need to shade above or below that line. Okay. Here's another one. X plus 2y is less than or equal to 0. Okay, so again, graph the line first. In this case, I would do it by finding the intercepts. Right? Plug in our zeros. Just because it's already in standard form, so why work harder than we have to? So if we plug in 0 for x, y is going to have to be 0. If we plug in 0 for y, x is going to have to be 0. Wait a second, that doesn't work, right? We get 2 of the same intercept. And if you look at the graph, you can see that it goes through the origin. So the x and y intercepts are the same. This is not enough information to graph, right? So we need to find a slope. So you have to get y by itself. You'll find out the slope is -1/2, and then you can graph from there. But that's all beside the point. As long as you can get the line graphed, we're in good shape. So graph the line, then we have to decide is it solid or dotted. In this case, our inequality does have the equal to, so this will be a solid line. So it'll just be like graphing an equation. So we draw our line, we make it solid. We have to decide which side of the line we want to graph, or shade, excuse me. We can't plug in 0, 0 this time because the graph goes through 0, 0. We're going to have to pick a point that's not 0, 0. And it can be literally any point, but again, let's not make it harder than it has to be. Let's use 1, 0, easy numbers. In this case, we get the solution that 1 is less than 0, which obviously is not true. That means that this point is not a solution. And so all of the points on that side of the line, not solutions. We are going to shade the opposite side of the line, the side where the solutions are. Okay, so you don't have to test both sides of the line. Pick one side and test it. If it works, shade that side. If that side does not work, we're just going to shade the opposite side, and that's the end of it. Okay, so we shaded, we've graphed, we decided whether it was a solid or dotted line. We're done. In this graph, all of the solutions are in the blue. Because it's a solid line, every point on the line is also a solution, and that has to do with this piece right here. If it's equal to, the line counts. If it's not equal to, the line does not count. Okay, so take a second and graph this one on your own. You can just sketch it in your notes. It doesn't have to be perfect. So pause the video for maybe 2 or 3 minutes, sketch a graph, get all 3 parts correct, the line in the right spot, it needs to be solid or dotted, and decide which side to shade. After everybody has a couple minutes, go ahead and play the video again. and I'll show you what I got. Okay, so again, this is in standard form, so I would suggest we plug in our zeros. 0 for x, 0 for y. If I plug in 0 for x, 3y equals -1, I'm going to have a -1/3. If I plug in 0 for y, x is going to have to be a -1. So here's one intercept, -1/3, and here's the other one. So they're pretty close together. If you wanted to get a few more points, you could do that. We check the inequality. It is equal to, so it's going to be a solid line. Okay, something like that. Now I need to test where I'm going to shade. So 0, 0 is not on the line, so I'm going to use that because it's the easiest one to work with. So 0 plus 3 times 0 greater than or equal to -1. 0 plus, well, 3 times 0 is 0. 0 plus 0 is 0. Is that bigger than -1? Yes, it is. So this is a solution. I'm going to shade everything above the line. Don't go crazy with the shading. It just has to be enough that I can tell which side you shaded. Just make it neat and make it effective. Don't go crazy. You don't need to make that side of the line black or anything. Just make it so that we can see that that's where the solutions are. Again, in this situation, the blue line does count as solutions because it's equal to. Okay, this one, what do you notice? There's no x-coordinate. So this has to be a horizontal line. So remember, when we're graphing the boundary line, just for a second, pretend it's an equation. We all know what that graph looks like. It has to be a horizontal line. Okay, so we know it's going to be a horizontal line right here. Now go back and check, should it be solid or dotted? In this case, it's solid. Okay. And I'll rewrite this because I kind of covered it. We need to decide where we're going to shade. Y has to be greater than -3. The easiest way to think about that is stand at -3 and figure out where are the bigger y values. Are they above or below? They're below. Excuse me, they're above. Okay, so we're going to shade above the line. If you want to plug in a point, you can still do that. Plug in 0, 0. Right? 0 for y. The 0 for the x doesn't matter because there are no x's. Is that true? Yes, it is. 0, 0 was above the line, so we're going to shade above the line. It works the same way if we get something like this. X is less than -1. Again, pretend it's an equation just for a second so we can get an idea what the line looks like. We all know that's a vertical line right here at -1. Then go back and look at the inequality. Now, this one is not equal to, so this has to be a dashed line. Okay, it's in the same position, it's just dashed. So x is less than -1 was our inequality. Do I shade above or below? Well, it's a vertical line. We can't shade above a vertical line, right? It's going to have to be left or right. So just think about this for a second. X is smaller than -1. Here's -1. How do I get smaller in my x-coordinates? Do I go left or right? So just pick a point over here. Is that bigger or smaller? That is smaller. So we are going to shade this side. You can still plug in a point, just like we did on the last one, 0, 0. 0 less than -1. The 0 for the y-coordinate doesn't matter because there's no y's involved. Is that true? Yes. No, I'm sorry. No, it's not. So 0, 0 would be over here. It's not a solution. So we can't shade that side. So either way it works. With the vertical and horizontal lines, I think it's easier just to kind of think about what this means rather than plug in a point, but do whatever works for you. Okay, we're going to skip that one. Chapter 3, day 11. Okay, I'm not sure the page number is right, but this is correct. So again, hopefully there's enough time for you to finish the homework and not have any tonight. We are taking the quiz tomorrow, so be ready. Make sure to have your homework done and with you because you can use it on the quiz. And then have a great Thanksgiving break, and I will see you guys next week.